right now, the most weightless, ethereal technology on the planet, which is, artificial intelligence, it's just slamming headfirst into the dirtiest, most physical commodity on Earth.
Yeah, crude oil.
Exactly, crude oil. We spend so much time talking about AI as this, I don't know, magical thing living in the cloud. We always conjure up these images of invisible data floating around in the ether.
Right, like it has no physical footprint.
Right. But today, we are looking at a really fascinating stack of sources, including the latest Coda Daily Digest and some highly confidential internal visual intelligence briefings for today, April 3, 2026.
And I mean, every single data point we have is pointing to a massive, jarring physical collision.
It really is. So welcome to another deep dive. Today we are going to explore how a sudden, violent spike in global energy prices is forcing this high-stakes showdown.
Yeah.
It's creating two radically diverging philosophies for how developers and really tech giants in general survive what is coming.
It really is a profound collision of, well, two completely different eras of human industry. I mean, the digital and the industrial are finally meeting at the bottom line.
Yeah.
To understand the AI strategies we are seeing today, we have to start with the raw economic reality sitting right at the top of today's digest. U.S. crude just posted an 11.4% single-day gain.
Wow.
Yeah, closing at $111.54 per barrel.
But that is massive.
It's the largest single-day jump we have seen since April 2020.
And the sources note this spike follows strikes on Gulf energy infrastructure. But I want to clarify for you, the listener, we are explicitly skipping the military blow-by-blow here.
Right, yeah.
We have covered that geopolitical escalation for, I think, 3 straight deep dives now, so you already know the context there.
Right.
What we care about today is the sheer brutal math of that 11.4% jump.
Because that math changes everything.
Exactly. Like, how does a barrel of oil actually relate to an API call? Because for a lot of people, those two things exist in completely separate universes.
Well, the connection is direct. And it is entirely physical. We have this sanitized term, cloud computing. But the cloud is really just massive, sprawling warehouses of humming servers.
Just sitting out in a desert or an industrial park somewhere.
Exactly. And every single time a user sends a prompt to a large language model, those servers have to crunch an astronomical amount of math.
Right.
And that math generates intense physical heat. So to keep the servers from literally melting, you need massive cooling systems. Both the processors and the chillers require just unbelievable amounts of electricity to run.
So AI is effectively the new heavy industry.
Yes, and oil still runs the power grids that feed the factory.
So when the baseline cost of global energy spikes by over 11% in a single day, that isn't just, a headline for commodities traders in Chicago.
Far from it. I mean, it directly and immediately threatens cloud compute pricing across the board. It squeezes the profit margins of every single tech giant operating a server farm.
Right, because their costs just skyrocketed.
Exactly. Think about it. If you are charging a flat rate for access to your AI model, but the electricity required to answer a user's question just got 11% more expensive, your business model is suddenly bleeding cash.
It's unsustainable.
Right. This intense underlying economic pressure is the absolute mandatory lens through which we have to view the major moves happening in the AI space right now.
Which brings us perfectly to how the biggest player on the board is reacting to this exact energy squeeze. If compute is getting more expensive, OpenAI's strategy seems to be, well, building an impenetrable fortress.
Yeah, that's a good way to put it.
They just closed a historic $122 billion fundraise.
Which is just...
It's a number that is honestly difficult to comprehend, right? Even in the context of modern venture capital. And they didn't just sit on that cash. The Digest notes they immediately acquired TBPN.
Right, to aggressively expand their AI and machine learning capabilities.
Exactly.
And, that acquisition is a massive signal. TBPN operates essentially as a specialized compute infrastructure layer. OpenAI isn't just buying software startups anymore. They are buying the underlying scaffolding.
It's hardware.
Yeah, it's a classic defensive expansion. They are looking at the rising cost of energy and compute, and they are choosing to vertically integrate as much of the physical and digital supply chain as humanly possible.
The visual direction we have in the intelligence briefings for this specific story is really striking, actually.
Oh, the internal brief?
Yeah. It describes this illustration of 2 massive monolithic server towers facing each other against a dark void. One is sleek and black with the OpenAI logo, And the other is industrial, wrapped in copper and glowing LEDs, which represents TBPN.
Wow.
And there's this brilliant bridge of liquid light merging the two towers together, literally fusing their exterior panels.
That's quite the image.
It is. Swirling around the base of these towers are stacks of gold coins, clearly representing that $122 billion war chest. But here's the detail that really caught my eye. Floating above this entire scene is a legal contract, but the key lines are heavily redacted with thick black bars. The actual terms of this massive deal are entirely secret.
Right. And the deliberate opacity there is the point. I mean, we are seeing a hard, undeniable pivot toward closed ecosystems.
Yeah.
OpenAI is building a monolithic structure where they want absolute control over the hardware, the software, the models, and the deployment infrastructure.
I have to ask the obvious question here, though. If compute is getting astronomically expensive because of these global energy shocks, is OpenAI's strategy to just buy up absolutely everything and lock the doors?
Right.
Like, are they just trying to ensure they're the only ones left who can actually afford to play the game?
That is a significant part of the dynamic, yes.
Yeah.
I mean, when resources become scarce or prohibitively expensive, the entity with the deepest pockets consolidates the market.
Right.
However, simply buying up infrastructure doesn't solve the ongoing operational cost problem. They still have to protect themselves from those rising daily energy costs.
The electricity bill.
Exactly. And we see the specific mechanism for how they plan to survive that in another, well, seemingly small detail from the digest. OpenAI just shifted its Codex coding platform to a pay-as-you-go pricing model for developer teams,
Oh, right.
totally dropping their previous fixed-tier plans.
Wait, shifting to pay-as-you-go, because I read their press release, and they spin that as lowering the barrier to entry. They claim it's a win for smaller teams who don't need expensive always-on capacity.
They absolutely spin it that way.
Yeah.
And sure, I mean, it might lower the upfront costs for a weekend hobbyist, but let's look at the underlying economic mechanics here.
Okay.
When you, as a provider, offer a fixed-tier price, say $50 a month for unlimited queries, you're absorbing the volatility of the compute costs.
Oh.
If global oil goes to $111 a barrel and your data center cooling costs suddenly spike, but your customer is locked into that flat $50 rate,
Yeah.
you eat that loss.
Your margins just vanish.
Exactly.
So by shifting to flexible usage-based pricing, they are fundamentally altering who carries the risk.
Precisely. They are pushing the unpredictability of compute costs directly onto you, the user.
Yeah.
It completely protects the monolithic provider.
Wow.
If energy costs force the underlying compute costs up, your pay-as-you-go bill simply adjusts upward at the end of the month. It's a brilliant, if utterly ruthless, way to insulate their $122 billion fortress from global economic shocks.
So OpenAI's defense mechanism in a resource-constrained world is to consolidate everything, lock the ecosystem down, and legally pass the unpredictable cost of electricity directly to the developers.
That's the playbook, yeah.
But if you're Google and you see developers starting to panic about those rising unpredictable costs, you realize that vulnerability is a massive business opportunity.
Oh, absolutely.
Which is why on the exact same day, we see a totally diverging philosophy hit the market. Google just dropped Gemma 4.
Yes. Google's fourth-generation open-weight model. This is their direct counterpunch, and it is built on an entirely different economic premise than OpenAI's Fortress.
The visual we have for this in the briefing is beautiful, and it's the total inverse of OpenAI's Dark Towers.
Right.
It's a crystalline gemstone, cracked open along a perfect seam to reveal a glowing, intricate neural network inside, and the gem is hovering over an open, translucent palm.
Literally symbolizing the open-source release to the community.
Yes. Radiating outward from this gem are these tiny autonomous agent icons, miniature search cursors, code brackets, little robotic arms, all orbiting it like electrons around a nucleus.
Very cool.
But the crucial detail is the massive bar chart sitting behind the graphic. It shows a metric called intelligence per parameter climbing steeply, with Gemma 4 towering over all previous generations.
Intelligence per parameter. If you take one concept away from this deep dive, it should be that metric.
Really?
Oh, yeah. Parameters are essentially the synaptic connections in an AI model. They dictate how large the model is, how much memory it takes up, and most importantly, how heavy it is to run.
Okay, let me try an analogy here, see if I have the mechanics of this right.
Go for it.
If OpenAI is building this massive, hyper-expensive luxury hotel where you have to pay a fluctuating premium just to rent a single room, Google essentially just open-sourced the architectural blueprints for a highly efficient tiny home that you can build and run in your own backyard for pennies.
Well, I'd push back on that analogy slightly.
Oh, okay.
The tiny home comparison works for the physical footprint, yes. But a tiny home implies it can only do tiny things.
Right.
It's actually more like having the open source blueprints for a hyper-efficient modular factory. Think of parameters like the gears in an engine.
Okay.
Older generation models achieved higher intelligence simply by adding billions of more gears to go faster.
Yeah.
But that made the engine massively heavy, bloated, and incredibly fuel-hungry.
And when fuel, or in this case electricity, gets expensive,
Right.
that giant engine becomes a liability.
Exactly. So increasing intelligence per parameter isn't just making a smaller model, it's like reinventing the shape of the gears themselves.
Wow.
Google engineers have figured out how to get twice the torque out of half the metal. They are engineering a model that punches astronomically above its weight class without requiring a localized nuclear reactor to power the inference.
That makes perfect sense. If we trace this back to that $111 oil spike, the math of the old way stops working. You can't afford the electricity bill to run a bloated billion-parameter query in the cloud just to power a simple customer service chatbot.
No, it's financially ruinous.
Right.
By maximizing efficiency, Google makes open, agent-ready models strategically invaluable right now. Because Gemma 4 is an open-weight model, you can download it and run it locally on your own corporate hardware.
Or a much cheaper cloud instance.
Exactly. You aren't trapped in a centralized provider's expensive compute environment, held hostage by their pay-as-you-go rate hikes.
And the developer market absolutely knew this was coming. The digest notes that prediction markets on Manifold had Gemma 4 dropping in April at a 98.8% certainty.
They were waiting for it.
Yeah, it's already dominating the conversation online because developers are desperate for a viable alternative to closed model dependency.
It is an existential threat to the closed fortress strategy. I mean, Google is placing a massive bet that the future of artificial intelligence isn't one giant, impossibly expensive brain locked in a corporate vault.
Right.
They are betting the future is millions of highly efficient, capable brains distributed everywhere, running economically, even when global energy markets are in absolute chaos.
So we have this massive fork in the road, the fortress versus the hyper-efficient factory.
Yes.
But there's another layer to this dynamic that makes the timing so critical. This divergence in philosophies is happening right as the raw intelligence race at the very top of the industry seems to be hitting a ceiling.
The plateau effect, yeah. We are starting to see the law of diminishing returns kick in for these massive frontier models.
I have a stat here from the What LM March retrospective that illustrates this perfectly. According to their tracking, GPT 5.4 recently scored a 57.17 on the intelligence index. Gemini 3.1 Pro Preview scored a 57.18.
Wow.
They are separated by exactly 0.01 points. The giants are completely neck and neck, fighting over microscopic fractions of a benchmark.
And when the frontier models become practically indistinguishable in terms of raw intelligence, the focus of the entire industry naturally has to shift.
Right.
If you're an enterprise developer, you stop caring about who won the benchmark by 1/100th of a point.
Yeah.
What you care about is execution. You care about how reliably you can integrate that intelligence into a real product.
And that explains the absolute barrage of new developer tools listed in the second half of today's digest.
Definitely.
Because the core models are maturing and plateauing, the entire ecosystem is pivoting hard toward production. We are finally moving out of the phase where AI is just a parlor trick for generating funny poems and moving into the phase of heavy industrial application.
Let's look at the mechanics of some of these new tools, actually, because they signal a massive shift. Hugging Face just released TRL version 1.0.
TRL stands for Transformer Reinforcement Learning. It's a post-training library, right?
Yes. But what a post-training library actually does is vital here. It's the mechanism that takes a raw, unpredictable AI brain and trains it to safely and reliably follow specific instructions in a real-world environment.
Okay.
What's crucial is how Hugging Face framed this release. They explicitly stated they are moving from a research code base to a production-grade library.
Ah.
That is the signal. The industry is moving out of the experimental lab and onto the factory floor.
We see that exact same transition with a new tool called Solid. The digest highlights this one heavily.
Yeah.
Solid generates real full-stack web applications using robust frameworks like Node.js, React, and TypeScript.
Right.
But the visual briefing we have for Solid is hilariously aggressive. It shows a towering, cleanly architected skyscraper built out of sturdy, interlocking code blocks with a glowing deploy button sitting on the roof.
Nice.
But right next to it, there's this crumbling, half-finished cardboard mock-up leaning over, covered in red caution tape that literally says, prototype only.
Wow, shots fired.
Yeah, the source notes this is an explicit, intentional shot at older generation tools like Lovable. Solid is screaming to the market, we build things designed to scale for millions of users, not throwaway weekend prototypes.
And then you have tools tackling the unglamorous plumbing of software engineering, like intent by augment code. Intent handles what they call agentic Git workflows.
Okay, break that down for us, because agentic Git workflows sounds like really heavy jargon. How does it actually work?
Yeah, so instead of just acting as a superpowered autocomplete while human types, intent acts like an autonomous project manager.
Oh, interesting.
Reads the feature specification, clones the massive enterprise code repository, figures out which 5 different microservices need to be updated to make the feature work, writes all the necessary code across those distinct services, and then submits the final pull request for a human to review.
That is wild.
It is automating the complex, multi-step coordination of software development.
Okay, I need to jump in here with some serious pushback, because all of this sounds amazing in theory. We are moving to production-grade tools. But then I see another tool further down in the digest, Fabricate version 2.0.
Right.
Fabricate claims it can take a single-sentence prompt and turn it into a fully deployed web app. Front-end, back-end, database, server hosting, all wired together in one step.
Yes.
If we have agents just spinning up entire interconnected applications from a single sentence, aren't we just creating a massive pile of unmaintainable garbage code?
Right.
Like, if nobody actually understands the architecture because an AI built it from scratch in 10 seconds, how on earth do human engineers fix it when it inevitably breaks?
It's incredibly easy to assume it will just be a mountain of garbage code. And honestly, a year ago, your pushback would be entirely correct.
Right.
But you're looking at tools like Fabricate through the lens of old generation models.
Right.
What changes with these new production-grade pipelines isn't just the code generation itself. It's the automated testing protocols and guardrails that happen before a human even sees the output.
Okay, but still.
And your anxiety about maintainability is exactly where the smart money is moving right now. We look at the financial section of the digest. We find the answer to your exact fear. A company called Coda just raised a $90 million Series C round.
Oh.
And it was led by KKR.
Wait, KKR? The massive private equity firm.
Yes.
That's not typical Silicon Valley venture capital. That is serious, traditional, institutional money.
Extremely serious money. And what does Coda actually do? They don't build AI models. They build secure enterprise development environments.
I see.
They build the underlying infrastructure to govern how human developers and AI agents interact inside highly secure corporate networks. Institutional investors aren't just blindly pouring money into the frontier models anymore. They are pouring $90 million into the governance of those models.
Wow.
The enterprise market is demanding infrastructure built specifically to manage, secure, and maintain the code that AI writes.
So the paradigm shift isn't just from, what can AI write to what can AI build. The macro shift we are watching unfold is, how do we securely govern and maintain what AI builds in the real world?
Exactly. The novelty of generation is completely worn off. The brutal reality of maintenance has set in.
Yeah.
If you have an autonomous agent churning out millions of lines of code across your corporate repository, you need a highly structured, strictly governed environment to ensure that code doesn't become a massive cybersecurity liability.
Definitely.
KKR sees that the real bottleneck to AI adoption in the Fortune 500 isn't generation. It's enterprise governance.
It is incredible how all these disparate pieces from today's sources connect into one cohesive narrative.
It really is.
We started this journey looking at a jarring physical shock, a spike in crude oil to over $111 a barrel. And we saw how that physical event directly squeezes the profit margins of cloud computing. That raw economic pressure is forcing a massive fork in the road for the tech giants. On one side, you have OpenAI raising $122 billion, buying up physical infrastructure, hiding their deal terms, and building a closed ecosystem fortress where they pass the volatile, unpredictable energy costs directly onto you, the user.
Yep. And on the other side, you have Google capitalizing on that developer anxiety with a highly efficient counterpunch.
Gemma 4.
Gemma 4 is a strategy that relies entirely on open weight models and reinventing the gears to maximize intelligence per parameter. They are ensuring that even in a world of incredibly expensive electricity, AI can run efficiently and locally on your own terms.
Meanwhile, because those frontier models are hitting an intelligence plateau at the very top of the benchmarks, developers are looking past the parlor tricks.
Exactly.
We're seeing a massive pivot toward production-grade pipelines, from Hugging Face's new post-training libraries to enterprise governance platforms raising $90 million just to manage the code these AIs are generating. We are watching the digital world restructure itself to survive the realities of the physical world.
We truly are. And, connecting all of this back to the bigger picture brings us to a fascinating realization about where this industry is ultimately heading.
Yeah.
If global energy economics continue to tightly dictate the cost of cloud computing, if the fluctuating price of a barrel of oil remains the hidden variable in the cost of every single API call,
Right.
it raises an important question to leave you with. Will the ultimate winner of the AI revolution actually be the company that manages to build the smartest, most capable frontier model? Or, in a resource-constrained world, will the winner simply be the company that figures out how to make AI consume the least amount of electricity?
Oh, wow. That is a phenomenal question. We always think of artificial intelligence as a pure software race, like a battle of raw intellect.
Right.
But maybe the true bottleneck isn't the software at all. Maybe the smartest model in the world doesn't matter one bit if we can't afford the fuel to run the factory. Something for you to mull over until next time. Thanks for joining us on this deep dive.